Hello, everybody. Welcome to the InvArch Tinkernet guide that we have announced that we would release to all of you. My name is AJ. You can't see me. I'm the one recording from your point of view, but you can see Gabe, who is actually across the
Hello.
table from me. He will be showing you how to navigate InvArch Tinkernet, and we'll be presenting to you 3 different use cases. The first use case is an ebook literary use case. It's actually an ebook that I created in the past, but I decided, hey, why don't we use this for a use case? So the scenario will mint a PDF book into an IPF, create an IPS or IP set containing the IPFs, and then those will be minted into IPTs for somebody else. So, for example, an investor invested into myself to write the book where they get a percentage of ownership following the completion of the ebook. So I would mint the book into an IPF, create an IP set that contains the IPFs, and then it automatically gets an IPT or IP token. So then I would then go ahead and choose to mint more IP tokens for the investor to get their investment back, essentially. So yeah.
Yeah. So for starters, this is what's going to show up when you go to the polka.js/apps website, where we will have the interface for the testnet. Be aware that this is not a user interface, an end user interface. This is meant for developers. So right now, what we are going to test in the testnet is the chain itself, and not any actual InvArch customized UI. So this is the interface we're going to use. A lot of things here are going to seem confusing for a lot of people. So just pay attention, and if you need any help, just hit us up on Discord. I'm sure a lot of people are going to be there to help you. So when you first come here, you'll be thrown into a different chain. It will probably be Polkadot if you've never been to this page. And on the testnet, during the testnet phase, you'll be able to click this top left corner, and it's going to have a list of chains. So if you collapse this one, and if you go into test Rococo and parachains, you'll be able to see InvArch Tinkernet in there. And you can just click there and click switch, and it's going to switch to the InvArch Tinkernet. In preparation, I have created a few accounts here in Polka.js, which is another requirement. You need to use this. You need to have the Polka.js extension installed with your accounts set up. So I have created these accounts. They are injected here. For the first scenario, we'll be using AJ as the book publisher, and we'll be using investor to demonstrate the person that will receive a few IPTs of the book. So the Polka.js interface has this developer tab. This is where most things will happen. Here in Network Explorer, you can see also the blocks being produced and events, which will show functions being called. Well, here in developers, this chain state is where you can go and check the storages. For example, if there was an IPS already here, you could come here, IPS storage, and query an IPS ID. When you click this button, it would show what's on that storage. Here in extrinsics is where you can actually call functions. For example, IPT mint, and then we'll also be using this menu here, files IPFS. This is an interface in Polka.js that allows you to mint, to publish things in IPFS easily already here in the interface. So this is a very handy tool. And I already uploaded everything we'll be using except for the ebook itself. So I'll upload that to demonstrate. So you hover upload, and then in file, you can select your file. We'll be uploading this PDF. And then you can leave this one in the default. It would show a different one probably, but just leave it at that. And then let's mint that let's upload that with the AJ account. Sign and submit. It will prompt for the password. I set all the accounts in here to just use 1, 2, 3, 4, 5, 6. So I'll just start that. There we go, finished uploading. Here it is. And the actual chain, it will not use CIDs themselves. It will use the hashes. So I'll have this CID inspector tool open here, and let's already copy this and put it there. So the way this works is when I paste a CID, it's going to show me the hacks under here. So we will be using this to, let's copy this to Mint. Let's go over to developer, extrinsics. As the AJ account, we'll be going to IPF, Mint, and then as metadata, let's for example, let's just write book.pdf. As data, here we'll be using that hex. In data, we'll just be pasting that hash. And then we can submit transaction, sign and submit, and it will ask for the password again, so you can sign a transaction. There we go. And then if you go over here in the corner, you see the transaction going through. It already showed the event, but soon it will show here that it was successful here. So it's in the block, and here you see that almost every transaction has a balance withdraw event too, because this is for the fee. And then you can see IPF minted. The account was the AJ account. IPF ID in this case is 0. This is the first IPF we are running. We are minting this chain, and the actual data for that, which is the hash for the IPFS CID. We can see that in here. If we go to the chain state tab, we go to IPF storage, and we query IPF ID 0, and it's going to show here. So metadata book.pdf, owner and author. The reason we have owner and author here is that author is never going to change. This is always going to say who first created this IPF, but when you transfer this around, this is going to change the owner. When you put it inside an IPS, the IPS itself will be the owner of this. But then we have the field author, so we can always see who first created this. Let's put this in an IPS now. Let's go to extrinsics, IPS, and let's create IPS. So for metadata, let's call this, let's just call this published book. And data, we could add more items, more IPFs, but let's just keep this the IPF ID 0, which is the book we just minted. For allow replica, for this example, let's say that it's not allowed. No one can replicate this. Let's submit transaction. Back here in Explorer, if we wait a bit, we'll see that it will show the event for the IPS being created here. So IPS created, and what's not showing here but is actually happening too is every time an IPS is created, there's also the asset for the IPTs that's being created, and the account that created the IPS also got an initial amount of IPTs. So for example, let's go back in here in the storage, the chain state. We can see the IPS here, IPS storage, and here it is. You can see that it's a published book, IPF ID, and this account that shows here, this says that it's a parent IPS. It's not a child of another one. And this account, this is not the AJ account that we just used. This is the IPS account. So every IPS has its own account, which can be used to act as the IPS. Every modification in the IPS has to be called by this account. And the reason for that is because if we go to IPT and we query IPT ID 0, we'll see that that same account's here. We'll see that we have a supply here. Let's also copy this for now. And then if we query the balances for that same one, let's not include anyone here. we'll see that this is the actual AJ account, and we see this balance. So AJ has 100% of the tokens for this, which means AJ has 100% copyright ownership over this IPS. So now to complete this use case example, we can go back here to extrinsics, and with AJ, we can go to IPT and operate multisig. So this will allow us to create an operation as that IPS account I just showed. We don't have to include caller for this. We will be using IPS ID 0, and then for the actual function that account will run, we can go back to IPT and we can use the mint function. So IPS ID 0 for the amount. So let's just create a pretend number here. Let's say the investor is getting this amount of tokens. Let's pretend this is 10% of that, 10% of the whole supply. And then for account, we can select the investor account. So this IPT mint call, what it takes is the IPS ID for which we want to mint IP tokens, the amount you want to mint, and who will get that amount. So AJ is using the IPS account to do this call. What happens is, since AJ has 100% of copyright ownership, it will execute that for AJ. If AJ had less than 50%, because right now we have the 50% number hard coded. So if AJ had less than 50%, it would start voting, and as soon as enough people vote on it that it goes past 50%, then it executes that call. This allows for democracy to happen inside the IPS. So we can submit this transaction, sign and submit. 1, 2, 3, 4, 5, 6. And going back to Network Explorer, there we go. IPT multisig executed. This yes down here says that the call succeeded. This is the actual call we did. We did IPT mint for this amount, for this account. And here's what it actually called. IPT mint. Investor got this amount. So if we go back to chain state, if we go into the IPT module, balances for everyone, so we don't include the account, in IPT 0, we'll have the two balances. This is AJ, and this is how much the investor has. So right now, this means that in a real scenario, the investor would have this amount in actual copyright ownership over the whole project, the whole IPS. And we can see that that reflects in the IPT itself. You can see the complete supply changed. It added that amount to the total. If this were the case, that instead of having this amount and this amount, if they both had like the same amount, and we had like 3 people, for example, having the same amount, they would not have over 50% each. So they would have to at least 2 of them would have to vote to execute the same call. Otherwise, they can't operate as the IPS by themselves. They have to have the democracy acting on top of it.
Alrighty, and again, that was the ebook use case. Now we're on to use case number 2, which is music. The example that we prepared for you is 5 different people, 5 different tracks, creating one album. So let's say an independent group of artists decide to create an album. Each artist writes / produces 1 track each of their own to create a total of 5 songs. Each song is minted as an IPF or IP file. Then they are put together as an IP set, aka the album that they wanted to create. Then they release the album onto streaming services like Apple Music or Spotify. Let's say the album goes to number 1 and gets millions of streams. Each artist would earn 1/5 of the revenue because they all equally contributed to the production of the album, and there is no label involved. So I will pass it on to Gabe to then present it to you via Tinkernet.
All right, so back here to Tinkernet, we will disconsider these events. These are the events from the last example. They remain here until you refresh the page, so just leave them there. Back to the files section. We have all the songs here. We will be using these to demonstrate the use case. So I can, for example, demonstrate here that if we open this file, so this is actually transferring from an IPFS node, so that's why it takes a bit. Oh, it's actually going to Rust. I can show that these are actual music files by clicking this download button, and there we go. It starts playing the song. Okay, going here to back to extrinsics. There are a couple ways we can go about doing this, but to make this simpler for the example, the way we will proceed is, so artist one will mint the first song, and then artist one will create the IPS. Then artist one will have a lot of IP tokens on top of that, and artist one will give exactly one token to every other artist to let them add their track to the album. And after all of that is complete, artist one will burn all of their tokens so that artist one only has one token too. So everyone has the same amount. But to simplify, artist one will do the whole process as being majority owner, and then after that they will burn their tokens. So let's start by going to IPF. We're going to mint, and let's say this is guesses. So let's grab guesses. Let's copy this. Let's go and do the same thing we did in the last example. Let's grab the hash. Okay, now we can go here, extrinsics, IPF, mint, guesses.mp3, and let's add that here, the hash for the actual file on IPFS, and let's mint that. Okay, type the password, sign the transaction, and since we already had the last example right in this chain, this means that this is now IPF ID 1, because previously AJ minted another IPF and that got the ID 0. So the IDs, they are consecutive. Every time you mint something, it's the last ID plus 1. Okay, so now that we have IPF ID 1, we can go to the IPS module. We can create an IPS. Let's call this let's call our very cool album. This IPS will actually represent the whole album, because all the tracks will be grouped inside the set. This will be IPF ID 1. And we are not going to allow replicas. Let's submit transaction, sign, and type our password. Okay, so now we have minted this, and we should have pretty soon the IPS. There we go, IPS created with that one IPF. So now what we are going to do is we are going to follow that with artist2. Sorry, let's grab the file first. This is in check. Sorry about that. So let's grab this. Let's grab that CID, the data hash. There we go. So this track's called in check, and artist2 will be the one creating it. Mint in, let's call it in check.mp3. Let's mint it. Okay, while we wait for that to mint, let's proceed with artist1. So now artist1 goes back into his IPT, and he calls operate multisig because he has complete ownership over this, so he can operate without having to ask for a vote. What he's going to do is he's going to mint exactly one. Let's already do all of them real quick. Okay, so as artist1, let's use IPS1, which is the IPS that artist1 created, and let's mint for each other artist, let's mint exactly one IP token. Sign and submit. And we are going to do this for every single one of them, just so we can get this done with and we don't have to come back here and do the same thing later. Sign transaction and artist5. And here we can see these operations, they are going through. If we go back here, you can see that these multisig get executed, IPTs get minted. We go to change state and check that. You can check the balances for everyone. Let's just close these. Oh, sorry. For everyone in IPS 1. We'll see that they all have exactly one token, except for artist 1, and we'll burn those later. So, now that we have, let's check here, IPF storage, just check IPF ID 2. There we go. It's the one from artist 2. So what we can do now to include that is artist 2. We can go to IPT and we can also operate a multisig. What we're going to do here is we're going to include the caller so that instead of just calling as the IPS account, we include data that says we are artist 2, because then we can add our IPF. Otherwise, there's no way for the chain to know if you actually own that. So we're going to IPS, we're going to append IPS1, we're going to append an IPF ID. That's IPF2. We're not going to change the metadata, we're going to leave that as our very cool album. Submit transaction. 1, 2, 3, 4, 5, 6. And then we can come back here and we can see that a multisig vote started. What this means is that we need to have at least 50% of the owners agreeing. And since artist1 has a lot of tokens, artist1 has to agree with this. So we can check the storage for IPT, and we can see that multisig operation here. If we disable this, and here it is, that multisig operation. All we can do is we can copy this, we can go back into extrinsics, and as artist1, we can go to IPT, and instead of operating multisig, we can vote a multisig. That's IPS ID 1 and the call hash that we just got from the storage. If we submit this transaction, we sign it, you can see here in the network tab in the Explorer. You can see that this will display that there we go, multisig executed, and what that executed was this IPS append. So now if we go to change state and we check that IPS, yes, storage ID 1. If we check that, we'll see that it now has that original IPS ID 1 from the first artist, and then the second artist appended an IPF ID 2. Okay, so now all we have to do is the same thing for the rest of the artists. Let's go to files. Let's do this quickly. What his name was Lala. Okay, let's grab this. Let's come here. Let's get hash for that. Copy. Extrinsics. Artist 3. IPF. Mint. Lala.mp3. Submit transaction. Okay, let's wait for that. While we wait, let's already do this. Let's already go here. Operate multisig. Include caller. PSID1. IPS. Append. Append to IPS1. The IPF ID 3, which is the one we just minted. Yeah, that's right. Submit transaction. Sign and submit. Then we can go into the chain state while that loads, and we can check that again. Let's wait for it to go and block. Okay, there we go. Let's copy this hash back to extrinsics, back to artist1, IPT, vote. And then we submit this. Okay, so we can then go here, confirm that data actually worked, execute it, append it. There we go. Let's continue doing that. This next one, number 4, is called red light. Let's copy this. Let's go here. Okay, get the hash. Back here, extrinsics, artist 4, IPF, and mint red light .mp3. Mint, there we go. So now let's continue that process. We will, as artist 4, we'll start a voting to include our new IPF into IPS1. IPF ID 4, that's our new song, artist 4's track. Let's check that. Yes, that's correct. Submit transaction. Again, we can go see that it started. There we go. Multisig vote started. We can go change state. IPT, multisig, and grab that hash. There we go. We can go into extrinsics, and artist 1 is gonna prove that. Sorry, all right. Here we go. Vote multisig, PSID1, and the call hash. Submit transaction. Sign. Again, let's make sure that it passed. There we go. Multisig executed. Yes, that it passed. And IPS appended the IPF number 4. Now for the last one, let's go grab the file again. And the name is you asked. Okay, there we go. File CID. Let's plop that into our inspector and grab the hash. Extrinsics, artist 5 is going to mint that IPF. Sorry, what was the name again? It was US. U asked.mp3. Submit transaction. And while we're at it, let's start the vote. Bring multisig, include the caller to the IPS1. Yes. Append to the 1. The IPF of number 5. There we go. It already passed, so we can place this one. Sign. Again, we can see that the multisig vote started. We can go to the change state, IPT module, multisig, and we can grab that. This one. Now, again, as artist1, we can approve that. IPT, vote, IPSID1, call hash. There we go. All right, so we got all the songs, all the tracks inside of the IPS. Now the way that we can finish this off, we'll have to make sure that everyone has the same amount of IP tokens. So let's go back to change state. Let's go to IPT module. Let's check the balances of everyone in IPS 1. Okay, so just to make this easier, because it's a bit hard to count the zeros here in VR. Okay, so let's get this amount. What we're going to do is, as the artist1 itself, we can go and IPT, operate multisig, PSID1, IPTs, and let's burn them on IPS ID1 from artist1, just to get that amount correctly. Let's replace all of these with 9s. There we go. We can submit the transaction. And we won't have to vote for that because right now artist1 has over 50% of ownership. So it's going to be executed immediately. There we go. Multisig executed. IPT is burned. And if we go back now, change state, we check that IPT balances for IPS ID1 are how they should. There we go. And everyone has exactly 1 token. Just to check the IPS itself. And there we go. Our very cool album. We have all the tracks. If we go into, if you want to check the IPFs themselves, we go to the IPF module, IPF storage. Let's check, for example, number 3, and we'll have the data for that one. Lala.mp3 data, who owns it now, which is the IPS account itself, and who originally authored it, which in this case is artist3. So that's it for this demo.
And that is all for the music use case demo. So this use case will be used to demonstrate how you can create IP replicas, and I'll give it to Gabe to further explain that.
Okay, so this is going to be simpler and quicker to demonstrate than the last one. For this one, what we're going to do is here in our files, we have code. We have a lib.rs file and a cargo.toml file. This represents a Rust project. we are going to demonstrate IP replicas by making an IPS with this, and then Bob's gonna come up, is gonna show up, and it's going to create a replica. And then on Bob's replica, he's going to add this changes the diff file. This is just a mock file that represents a diff. So if you don't know about diff files, they represent, like, in this line, you are going to remove this, add this. So this is a way to demonstrate the changes in a file without having to recreate the whole file. You're only interested in what changed from it, and the lines themselves are changed. So this is what Bob's is going to add to his version. So let's go to extrinsics. Already have a Gabe account in here, and he's going to IPF mint. Oh, sorry, I forgot. Let's grab the CADs from these, the hashes. Okay, let's grab this. Let's actually leave them in a note. Let's grab a sticky note, because we are going to use two different CADs. So this one, let's grab, where is it? Here, this one. There we go. Digest X, copy. Let's put that in the sticky note. And let's go back here. So we are going to be minting as Gabe the two IPF files. This is going to be lib.rs. Let's grab that. Here it is. And let's also mint the other one, which is cargo.toml. So if we remember from the last demo, these will actually be IPF ID 6 and 7 respectively, because in the last demo we used IPF ID 5. So let's mint these. We'll also be demonstrating what we didn't show in the last couple examples. We will be creating an IPS with two IPFs instead of just one from the get-go. Create IPS. Let's call this, that was actually a project called Substate, so let's call it that. Let's add number 6. This is IPF number 6, and also let's add another item, IPF ID number 7. And for this example, we will be setting allow replica to yes, because we want people to be able to create replicas of that. So let's submit transaction, sign and submit as Gabe. Go to network, see the two IPFs that we just minted, and also the IPF that was created just now. So this is IPF ID 2. Let's go to extrinsics now. What we can do, actually, let's go to change state, IPS, and let's query number 2. There we go. If we see in number 2, we have the two IPFs, and we have allow replica set to true. So now we can go here. Let's use Bob as the one creating the replica. Bob's going to go to IPS, create replica, and the original IPS ID will be 2. Submit transaction, sign and submit. Now while that, let's actually show the event for that. There we go, IPS replica created. So the replica itself becomes a new IPS. So the original was ID number 2. This replica is ID number 3. So now let's actually show the storage for that. Let's show IPS storage 3. And then we can see that it has the same metadata. It's a different account because it's a different ID. Has the same data, same IPFs. But in the previous one, in the original, IPS type was normal. This one, it says IPS type replica, and this number, this is the ID of the original. So a replica will always have a pointer showing what's the original. And a replica, for now, does not allow other replicas. In the future, we'll have licensing functionality, so we'll have more complex types for replicas. But right now, replicas themselves cannot be further replicated. So continuing this, now that Bob has his own version of that, what we can do is since Bob has a replica, Bob is the owner of that, the sole owner. He can operate multisig. Actually, first, let's go back here. Let's grab the file first. So Bob's going to introduce these changes. Let's grab the hash for that. There we go. Now let's go back and do that. Now Bob's going to create that IPF. Let's just call this changes.diff. Go, it's minted. And while that's loading, we can already prepare this operation. Operate multisig, include caller, because Bob owns the IPF and we have to address that. This will be IPS 3. Let's go to IPS and append. Again, IPS 3. What we're going to append is an IPF, which is now 8, since the last one was 7. Let's actually, no, let's leave this like that. Let's let people explore some other options. Let's sign this and submit. Explorer. We can see that we just minted number 8. And there we go, multisig executed. We appended ID 8. Let's go to change state. We can see an IPS storage, number 3. If we query that, we can see that it now has also IPF ID number 8. And it's a replica of 2. So let's check what happens to 2. Nothing. 2 remains like he originally was. So these are now 2 separate, completely independent IPSs. The difference is this was originally a replica of that. So this can now be built upon and explored further, and it can further deviate from the original, but this allows anyone to start with your base, with to copy the base that you have, and then start building what they want to on top of that. So this was the example showing that a developer can what we call in Git, a developer can fork someone else's code repository, and then they can start building their version on top of that. So in the future, the protocols will be different from this. This is just a simple demo, but in the future, with GitArch, there can be the actual way that Git handles files can be done on chain. We don't have to just mint a file saying the changes in a diff. It can be the actual Git protocol on this.
Awesome. Yes. So this is, again, the InvArch Tinkernet guide for all of you. We decided to launch it a few days before the actual launch of the InvArch Tinkernet, so that you can get a feel of first glance view on the actual Polkadot.js interface and how to navigate, basically really basic things with the InvArch Tinkernet. But with that being said, I hope all of you have enjoyed this. I want to thank Gabe for coming out I appreciate his time and for being here and showing all of you how to do all things. Any last words, Gabe? Any last notes for the audience?
So
Yeah.
I would like everyone to have fun testing out the testnet because we work hard on these pellets, and we want people to break them. So as counterintuitive as that sounds, we want people to actually find everything they can to explore what they can do with it, to go wild on it, and everything that you have to report back, we will likely be there with you guys on the Discord and checking Twitter. And if you find any issues, we'll be there to fix them. We'll be there with you guys.
Yes, perfect. This will be primarily on YouTube, so feel free to load up the comment section if there's anything awesome that you find, if there's anything that's wrong with it, any errors, anything at all. Please don't be afraid to flood comments. You can also find us, as you may know, on Twitter. All of our social media links will be down below in the description box, so if you need to reach out to us, feel free to do that on any of our platforms. And we truly want, especially with the devs that are going to come out, please let us know what you think, your thoughts, so that ultimately we will build the best technology out there. Which is
and also please do share any ideas and any use cases that you guys come up with. We would love to hear about them.
Awesome. Beautiful. Alrighty. So we'll see you again March 25th to the 31st is when InvArch Tinkernet will be running. It'll be your sandbox to play around with. Alrighty. See you later.
See ya.